Okay, today we're going to learn about two different graphs and how to find the probability within them. So there are two types. One is called a uniform distribution and one is called a normal distribution, which we've talked a little bit about, but we haven't really talked about the standard normal distribution, which is what we'll be doing in this section. So both of these graphs are what you use for continuous data. And so what do I mean by continuous? Like, what's the difference between continuous and discrete?
Just like discrete.
You can count continuous, you can
One's a measurement.
Yeah, so one is a measure. It has intervals. And discrete is something that you count. So for uniform and for normal distributions, to find the probability of something occurring, it's going to be in an interval range, and you're going to measure the area under the curve. And we're not going to be doing any fancy integrals or anything like that, but we are going to be finding the area under the curve using our calculator. So in order to be a continuous graph or continuous function, it has to fit two conditions. The first one is that the entire area under the curve is going to equal 1. So the two types we'll learn today are normal and then uniform, which looks like a rectangle. If you went from negative infinity to positive infinity, or from, the bottom to the top, the area is always going to equal 1, like 100%. So if I were thinking about test grades, you can only make between a 0 and a 100. So 100% of the class made between a 0 and a 100. What's the probability of you making between a 0 and a 100? 100%. Okay? If I shortened that interval and I said, what's the probability of you making between a 50 and a 60, or between an 80 and a 90, that's when you would be just looking at a certain shaded area, but it's not 100%. And then the second condition is that the height has to be greater than 0, so you can't have a negative. And the height just means from your x-axis to the peak. So this vertical distance has to be a number between 0 and 1. Just meaning you can't have a negative. So first type is a uniform distribution. That's the one that looks like a rectangle. And something is even, if it says evenly distributed, that's the same thing. So if I said, if I had you roll a dice 100 times, the chances of landing on 1 through 6 would all be the same. So you would expect to land on 1 through 6 the same amount of times. So here is something that you would see, like a word problem, where it's going to give you the range of x values, and you need to construct a uniform distribution, and then you can answer questions based off of that. So the example says you have a friend that is always late. That could be you that's always late. Let the random variable x represent when you are supposed to meet your friend until he shows up. Suppose your friend could be on time or up to 30 minutes late. So I've got a range from 0 to 30. That's going to be my range. This person can be 0 minutes late, it means they're on time, or all the way up to 30 minutes late, but they're not going to pass that. Then it says that each time is equally likely. So he has an equal chance of being 1 minute late, 2 minutes late, 3 minutes late, etc., all the way to 30. So equally likely, that's a key word that it's a uniform distribution. And it's going to be important. Right now I kind of have them sectioned off, but on the test, it's going to be up to you to decide, do I use a normal distribution, do I use a uniform? And you just have to use context clues to understand that. So it'll either say uniform, it'll say equally likely, it'll say even, something like that will be an indicator that you're supposed to use a uniform distribution for that. So the steps that you want to go through when you have a question like this is you want to draw your rectangle, which I have one made for you, where you're going to label your minimum value and your maximum value. So the left-hand side is going to be at 0, and the right-hand side is going to be at 30. So I'm going to put a 0 here, 30 here. That's my min and my max, if you want to write that in, just so that you know. Now, this entire rectangle, if I took the area of it, the area of a rectangle is what? Height times length, length times width, whatever. I usually say base times height, but however you prefer to write it, length times width, whatever you want to do. To make the entire thing equal 1, then I need to choose my height. In order to do that, it is always 1 over whatever your range is. So in this case, my height is 1 over what? 30. Good. Reason being is because you want your area to equal 1. So 1 equals my base, which is 30, times 1 over 30. That equals 1. So that's why we make our height 1 over range. You do need to memorize that because it's, when you're making your uniform distributions, you have to draw this picture. They'll never give you the height. Okay, they won't give that to you. That's something you have to add in. So you must add in yourself. From there, it's going to ask you questions of probability of intervals. So, in this case, it says, like for part A, it's going to say, what is the probability that your friend is between 10 and 20 minutes late? Now, I do want you to show your work on this when I'm grading it on the test. I'm going to expect that you show your work because it could be really easy to just give me an answer. But I want to find the area of this shaded region right here from 10 to 20. So how I ask you to show your work is I want you to show me the interval that you're finding. So I'm going to say P, which is probability. 10 is less than or equal to X is less than or equal to 20. So that's telling me what the interval is. Equals. Then I'm going to take base times height. So what's my base in this case? 10 times 1 over 30, which is my height, which gives me 10 over 30, which reduces to what? 1/3. Good. So on my math lab, it may want you to do decimals. So I prefer, I would take a fraction or a decimal, but on my math lab, it may say decimal.
What do you prefer?
Either one.
Okay.
If you want to keep it consistent and just do all decimals, because that's what my math lab says, then do that. But
Let's do fractions.
yes.
For C, I included 0,
I did too.
But 13 minus 0 is still 13.
but it's including 13 and 0, so that's 14.
13 minus 0 is the range. It's 13 minutes.
They can't be 0.
When it's continuous, you're including that value, but it's still, like, less than 13 and less than or equal to 13 is still going to be 13.
Yes.
So up to 13. So for the range,
We're including 0 as a number.
You can't do 0 minutes
Because I had
late.
asked for like the 3 to 9, is that including 3 and 9? You said yes.
yeah, so 9 minus 3 is 6.
Just do the numbers.
13 minus 0.
Why don't you just do the numbers?
To do the range, you do 9 minus 3. You do yeah.
So it's not including 3.
In a continuous function, it is over an interval. So if you're doing from 3 to 9, you simply take 9 minus 3. If it were a discrete, discrete is when you count. So that's when it would be 7. But when it's continuous, it's the area under the curve. So it's between 9 and 3. The range of that is 6, if that makes sense. Because it's over an interval of time. So if I said,
Greater than 3, but less than or equal to.
mhm.
That's our concept.
Yes, Tana.
What if I put the 0 is less than or equal to X less than?
You can do that. Yes.
Oh wait, I just did like the 0 and then for like 25 I did 25 less than or equal. And then
That's fine. Yeah, if your interval is different than mine, that's okay. Yes, Ben.
That doesn't matter if it's greater than or equal to.
Nope, they're the same in a continuous. So if you just said less and less, that would be the same thing because in a continuous function, they mean the same thing.
Wait.
Because here's the thing. Listen, and this let me show you why. If I had my rectangle, and I said, what is the probability of X exactly being 3 minutes late? So this little line right here. X equals 3. There is no interval. There is no width. So it equals 0. Because base times height would be 0 times 1 over 30. So you have to have some sort of range of values or an interval in order to get an area under the curve. Because if there's no base, I'll never say what's the probability that you're exactly 3 minutes late in a continuous function. Okay.
Could you look at
D.
P's here? P's.
We wrote
We
it
did
in
it.
a way. Is that
That's fine. Yeah. Because it only goes up to 30, so that's okay.
And this one.
And then, like I said, if you want the decimals, you can also do that. I don't know what 13 over 30 is or 1/6, but you can also put them as decimals. 0.43, and then what?
0.16 repeating, but it's like 1/6.
Okay. Okay, let's look at example 2. Example 2, it says the manager of a local soft drink bottling company believes that when a new beverage dispensing machine is set to dispense 7 ounces, it in fact dispenses between 6.5 and 7.5 ounces inclusive.
Random.
Suppose that it has a uniform probability distribution. So what's our first step? We're going to do what? Draw that rectangle. What's my 2 end points? 6.5 and 7.5. And what is my height? 1. 1 over 1, so just 1.
Look at the Lord.
Okay, try parts A and B.
Where did you get 1 over
1 over range
1?
equals 1 over 1, which just is 1.
Wait, how do you know the range is?
7.5 minus 6.5. Okay, here's what I got for 2. Good with that? Okay, try the last one. It's different, but I think you'll be able to figure it out.
No, I'm lost.
So here it gives me 2 pieces of information, but it doesn't give me the min and the max. It gives me the max and the range. So I'm going to draw my rectangle. I'm going to put my max at 90, but my range is 15, so what's my minimum? And then my height is 1 over 15. Good. Part A, probability that it will be above 80. So equals 10 times 1 over 15, which gives me 10 over 15, which reduces to 2/3 or 0.667. If it's between 80 and 85, then the base is going to be 5 times 1 over 15, which gives me 1/3. Or 0.334. Not bad. Okay, so we've talked about the normal curve, finding the area. We talked about the empirical rule. If you go out 1 standard deviation, that's how much percent? 1 on each side is 68, 95, and 99.7. Right? So a standard normal curve is when standard normal curve is when your center is when your mean is 0, your standard deviations are 1, and along the x-axis are individual z-scores. So above and below the mean. So on that homework check that you just had, I think you got 2.31. What is it? Like if I were to interpret that, where would that person fall? Be like right here. So that means they're 2.31 standard deviations above the mean. So that is their z-score. That's how many standard deviations above or below the mean. Yes?
When it said the more extreme standard deviation, would that mean
The bigger one.
or furthest from 0?
Furthest from 0. Okay, so we're going to be able to use our calculator for this. It's giving me z-scores, and it wants us to find the area underneath the curve. So I printed out normal curves for you to start with, but I want you to get in the habit of drawing them and shading in the region that you want to find the area for. So 2.45, I'm going to This will work. I'm going to, it's going to be somewhere around here. I want the area to the right because it's greater. Now, I showed you guys in the calculator how to find that. It is the normal CDF function. So I want everyone to get to there. This is how you're going to be able to show your work on these parts. You're going to actually write in what you typed in the calculator. So you're going to write normal CDF Is everyone there on the calculator? Who?
I know how to get there, but I don't have my
Okay. If you have an 84, you go to second.
Oh, bars.
Vars 2.
Oh wait, I did find it on the.
If you have the Inspire, then you go to menu. Stat. Distributions 2.
So for upper,
From here, so once you get to normal CDF is used for area under the curve. So I want my lower, my upper, my mean, and my standard deviation. In this case, if I'm doing greater than 2.45, that means my lower bound is going to be 2.45. My upper bound is going to be infinity. To represent infinity, I personally will do 2 to the 99th power. Because that's like 2 times 2 times 2 times 2. There is an infinity button, but it doesn't work in the Inspire on normal CDF. It'll say error. Now, my mean for all of these is always 0, and my standard deviation is always 1. We'll get into examples next class where that's not necessarily the case.
How do we get to 0?
The mean and the standard deviation, because this Z right here tells me that it is a standard normal, because it's giving me a Z-score. When it gives me a Z-score, my mean and my standard deviation are always 0 and 1. So when you type that in, what do you get? 3 decimal places. Good. 007. Ah. Okay, I want you to try B through D. So make sure that you also shaded in the normal curve, because I will expect that on the test, like the shaded part. Questions about that?
Yeah, on the B.39, wouldn't you be closer to the right than to the left?
No, because it's a less than.
Okay.
And it's like 0 is in the middle, so 0.39. I could have even probably shaded it a little bit closer, because it's just 0.39. Yes. The probability. So what's the probability of having a Z-score less than 0.39?
That's how we know figure out.
So it's giving you the area under the curve, but it wants to know what the percentile is of that. So for E, I've got this normal curve. My area is 60%. Okay, 60% is shaded, and it's a less than. So a little bit above the middle. This is the shaded area. I want to find what my Z-score is at the 60th percentile, because it's at or below that value, okay? So I need to figure out what my Z-score is. Now, there's 2 ways you can do this. You can either do it by hand or you can do it in the calculator. I'm going to show you both ways, because you may forget one or the other, okay? If you do it by hand, then you need to find, well, I'm not even going to show you by hand. I don't like it. I'm just going to show you the calculator, okay?
I was going to say, you guys do that for no reason, because none of us finna do it by
So it's called inverse norm in your calculator. So the way that you got to normal CDF, so second, vars It's not option 2, it should be option 3. For the Inspire people, menu, stat, distribution, and option 3. Inverse norm.
So for the area, do we put the decimal or the?
So for the area, you're going to put in the percentile, so 0.60. The mean is still 0, and the standard deviation is still 1.
We have to write it out.
Yes. So what do you get? 0.25.
Show us how to do this.
Oh. You could. Okay, the next one is different because it's a greater than. So if I have my normal curve, the area above is 28%. So 28% is above, but I want to find this z-score. So when it's a greater than, you have to do 1 minus 0.28. It's going to be at the 72nd percentile. Okay, so when it's a greater than, you have to take the opposite. Because if 28% is above, then 72% is below.
So you only do the below for this?
For a greater than. So inverse norm, 0.7201.
Yeah, 0.58.
0.583? Okay.
So, if it's greater than, you just want the less than.
Less than, you do it at that percentile. Greater than, you do it at the 1 minus that percentage. Because whatever number you're putting in here is the area below.
Area below.
Looking at G, what do you think that I would do for this kind of question?
1 minus 0.5.
Inverse norm, 0.9. Because it's the top 10%. So if you're in the top 10% of your class, you're at the 90th percentile. What do you get?
I got 1.28 for that.
That sounds right.
I did 1.2.
And then lastly, for H, I want the z-scores, so that means 2 of them. I'm going to have to do this twice. For the middle 80% of my data. So what 2 percentiles will I put in? If I want
20 and
this to be 80%,
20 and 80.
that would only be 60%.
So 1 and 90.
10 and 90,
Does it matter what you put in as long as it just adds up to 80?
middle 80%.
That's so tricky.
So like if it says 60, should you put like, or if
If it said middle 60%, you would do 20 and 80.
so it has to be the exact.
Oh, so like the big number minus the small number equals the middle.
Wait, but then, do you do it for 10?
So I'll do inverse norm
Oh yeah, what would you do for 10?
of 0.10001 and inverse norm of 0.90 which we already got.
Wait, but I thought you couldn't do it when it's above.
It's the middle 80%. So I'm at the 10th percentile on the 90. You should get negative 1.28. Is that right?
Yeah, that's right.
They'll always be complementary to each other. One is positive, one is negative. If you're doing mirror images from the center. So like my center is right here. They're both equal distances away. They're going to be the same number, just positive and negative.